Hi, and welcome to another Rigonomicon.com tutorial and rigging basics. For those of you that are not aware, these videos are part of a series of videos and are on a web page, which is a companion page for my students that are learning how to rig. But I made it available so that anybody that goes to the web page can benefit from this and take a look at what's available. And there's all kinds of stuff here on this webpage. There's lots of information about the like best practices and so on. So anybody can go to this webpage, and this is where you'll find this very video. It should be in the basics of rigging, unless I replace it. So you'll always have the latest version of everything. So for today, we're going to be talking about constraints. Constraints are a very important part of rigging. Before we even start, I've got this little file that I've set up with some objects that we'll be pulling from. We'll duplicate them and pull some add some constraints to them. But before we even start adding constraints, we need to define the difference between constraints and just normal parenting and hierarchies. So in a hierarchy, I'm just going to press Shift here to see the entire hierarchy of this one over here. I color coded it so it's easier to see, especially when it comes to YouTube compression. So this object here, that is the child node, the leaf node of the hierarchy, and it's got a parent which is joint 2, and there's the top parent which is joint 1. So basically, hierarchies are always just showing you the basically the dependence order, and the last object will inherit whatever. So if you do anything to this one, like God save you if God help you if you do this, but if you scale, well, it's going to be inherited by the objects at the very bottom. If you decide to move it, it inherited that motion. If you rotate it, well, it's inheriting. And the thing is, its local values aren't being updated. It's just along for the ride. And there's more to inheritance than just that. It's not just the transform. It's also could be the wire color. It could be its visibility. There's a lot of things that you can inherit. So it's an all-in-one package where you're inheriting things. And also, a very important thing to note is that when you have a hierarchy structure, it's actually very efficient. It puts things into little buffers and says, okay, these values don't need to be updated because I've already calculated them, and now when I'm rotating this thing, well, I'm updating, I'm not updating the child node. I'm just updating the parent, and it's inheriting the predefined, like pre-calculated stuff that hasn't been touched. So it's very efficient. You never want to use a constraint when a parenting or a hierarchy can be used. That I think I might turn that into a golden rule, because I've seen some atrocities out there. I've seen some rigs where people were using position constraints instead of just normal parenting, and things break very easily when you do that kind of stuff. Okay, so now I'm going to explain what a constraint is versus this hierarchy thing that I just explained. So, a constraint is kind of like a command where it overrides and says, okay, that position of yours over there, instead of inheriting the values, I'm going to override it, but just the position or just the rotation or just the scale. Constraints are very like they're very targeted. They specifically control one thing or another, and this is very handy for rigging because it allows us to override a hierarchy so that we can do things like have feet plant to the floor, stick to the floor. You can have IK, which will calculate rotation value. So here, I'll give you an example real quick. Most people don't think about it, but an IK is very much, if I go into skeleton and I go create IK handle, and then I click on the child or the leaf node, and then click on this, I will have an IK. So now the rotation's no longer being calculated um, by what you do as keys, although you can combine them. And now you have yourself a very interesting setup where it will where this position goes, it will calculate the rotations necessary to match it, and you have some features in here to be able to control in what direction the elbow or knee is pointing. So that's just an example of what you can do with this kind of stuff. Now I'm going to go into basically what constraints are available inside of Maya, and any software that you're using, I guarantee there is a solution for each one of these. So let's start by talking about a point constraint. Okay, I think that one's one of the easiest ones. So I'm just gonna bring this over here. I press Shift, by the way. It's something that got brought to Maya from another software. Allows you to duplicate objects very quickly. So in this example, what I'm going to try to do is I'm going to use the point constraint to make this object lock onto this object, and we're going to see what that does for point constraint. Basically, point is unfortunately a term that I don't like too much. It's a position constraint. It's just another. It's just a bad term, I guess. And I'm going to open it up with the options by pressing the little square here. And the order in which you select things when you add a constraint is very important. It's kind of the opposite of how parenting works, where you select the child and then the parent. Here, it's almost like the opposite. It's definitely the opposite because you can constrain an object to multiple points. So if I grab this thing first, which is the object that will do the controlling, and then I select this object last, which is the one that's going to be controlled, I can create a constraint. Now, a fast way to know which is which when you're doing this stuff is that in a constraint, the last thing you select will show its. If you have the channel box open, it'll show you all the channels. And if you have something like a translation or a position constraint, it will add these little blue things here saying that it's being calculated and no longer manually done. So if I go in here with this selection order, and I'm going to remove maintain offset. That will become very clear very soon. I'll do it again later with that option on, and you'll see what the difference is. And for the most part, just leave it the way it is and apply. So now what it's done is it moved, like this is the object with the blue thing that I was mentioning before. It's now saying that these values are being calculated so that this object now matches the other object in position, or as Maya calls it, translation. So now if I grab this object and I move it around, it follows, and there's no issue with that. But you'll notice that the rotation does not affect it, and it's easy enough to understand. You basically said, I want to override the position with a point constraint. And everything else, there's no inheritance of any other kind. So if I scale this object, it doesn't do anything to it. If I rotate it, it doesn't do anything. If I change its wire color or anything else that might be inherited, it won't affect it. The only thing that it affects is the position in which it is. All right. So you basically did a little override, but you have to remember that this calculation is live, meaning every time you make an adjustment to this, this is constantly being updated so that its values are calculated here. It's not like a hierarchy, like I mentioned before. A hierarchy it has like this stuff would not be calculated if it was a child node of this object, and that's these little tiny things add up. The more constraints you have, the more of these IKs that you're kicking in the background. All of that stuff adds to poor performance inside of your viewport. Your frame rate can drop if you have too many constraints and so on. Maya has improved considerably with multi-threading, so you have less and less of these problems now. There's more power. It's no longer just CPU driven all the time. Now you have, and here's the thing: I'm in the process of actually writing a tool called the bacon strip. Bacon strip means it's not just a strip of bacon; it's to bake and to strip. Basically, you bake the animation down, and you remove the all the rigs and stuff. Anyways, the tool is got a whole bunch of its new kind of constraints, which fully uses multi-threading, and in cases of like the visuals, it's using GPU acceleration. So it's a beneficial tool that will take full advantage for performance inside of Maya. It's a free tool. Once the tool's up and running, I recommend you take a look at it. Like just this alone to be able to draw this quickly and easily and efficiently is important. And so now we're going to continue with what we're doing here, so we can see what a rotation constraint does. So I'm just going to grab these two, make a new version of it. And now I'm going to select this object. That's my cat if you can hear him. He wants to be part of the video very badly. Uh, all right, so what I'm going to do now is I'm going to use the orient constraint. Pop that out. I'll remove the maintain offset. Same thing. That one first, this one second, and you'll see that there's nothing on the. It's the last thing that got selected that gets shown. If I add it now, you'll see that it seems like nothing happened, but you have those little blue boxes, which means now if I select this object and I rotate it, it'll figure out how to get it to match the two, regardless if it's in a hierarchy or not. All right. So if we could test this on an object that's a little different. So if I wanted to, I could grab this. In fact, you could probably go from here to there. Actually, we'll use a constraint. Okay, I'll use a position constraint. Point constraint, apply. Now it's over there, and I'm going to parent it to the that node there by selecting it first, and then what the parent is. And I've pressed P, and you'll notice that it is now part of that hierarchy, and it didn't change at all. But it's still calculating. It's still calculating what the rotation should be to maintain equivalency to this one. So if I rotate this, you see it's updating, and if I usually do the rotation here, it's maintaining that orientation regardless of the hierarchy, because what we saw before, this should be following and inheriting the rotation values, but it's not. It's maintaining its position. And also that constraint we just added, well, we should remove it now that it's been parented. But if this was not linked, or rather not parented, I'm going to press Shift P on it. Now it's unparented, and you might notice that it looks almost exactly the same. Well, it looks exactly the same as what we had before, because it's doing an update in constraint as well as rotation to be able to match it. Now, also, if you were to scale this, it will not inherit scaling of any kind. So this is how you can get past all those hierarchies, and you can override things. So now I'm going to do another one. I'm going to do a scale, and this one's pretty self-evident. So I'm going to bring that over here. I'm going to select this in that order. I'm going to go to the scale. Maintain offset is off, and presto, it's now connected. But if I take this, I move it, nothing. If I rotate it, nothing. If I scale it, presto. So it's connected. One is affecting the other, and only that one thing. It's very targeted. So the other thing that I'm going to go through is the offset, the maintain offset. It's very, very simple. Up until now, if I did a position, if I did a point constraint and I had it off, it would make it pop to the place because it has to match the two positions 1-to-1. Now, if I undo that, and I tell it to remember, now I apply it, it will remain where it was when I created the constraint, and now it will maintain that offset. So it's basically following what this thing, wherever it goes, regardless of orientation, because it's a point constraint, and it allows me to do that. Okay, so to move it around relative to that offset, and that can be very handy, especially when you're dealing with rotations. Don't worry about Euler issues with the maintain offset. In the case of an orientation constraint, under the hood, it's using a quaternion, so it's safe. You don't have to worry about that. So now what I'm going to do is I'm going to do one more. You get the picture. It's like an aim constraint is something that just points at another object type of thing. So, well, here, tell you what, we'll just do it real fast. I'm going to make it point to that object with the x-axis, and to make sure I know which one the x-axis is, I'm going to grab the other two axes and make it small. Right, so now that we can see which is the x, and I grab it like this. I go aim, we're going to ignore the offsets. The aim vector, meaning the axis which is going to be aiming, is going to be x. It's already set up, so 1, 0, 0 is x. The up vector, meaning the thing that it's going to use as a reference to be able to control how it rolls relative to that. Because if you think about it, just having the x-axis point on an object, you still can spin it all you want, and it still works. So you need to have some form of control. So we're going to say, in this case, we're going to use the y-axis, which is pointing upwards, and we're going to lock that. We can lock it to the world so that it always points up relative to the world. And now I'm going to press apply. What you're going to find is that it now aims at it. And no matter what you do to this object, if you move it around, it continues to aim at it. And this is great for having a head look at a target and so on. All right. There's no scaling or anything. That's just a perspective thing. So that's how an aim constraint works. The next one I'm going to do is probably the last one. So I'm going to grab this setup, and we're going to do that IK again. And I'm just going to go skeleton, because for whatever reason, the IK is in skeleton and not under constraints, even though it technically is very much a constraint. And I'm just going to click on these two. Boom, boom. It did a little. It did a little wiggle because of the. Actually, you know what? I'm going to go over it because it's important to understand why it did that little knee-jerk reaction. So if I grab this thing and I move it like so, and you'll notice that if I select any bone inside, there's these rotation values. So all I need to do is basically freeze it. So if I go into freeze, I want to freeze the rotations. You apply them. That way, this is the initial. It also becomes the preferred angle when you do that. And that's important for the IK to work. This is why we have to use joints in Maya. It's a Maya specific thing, but for the most part, this works exactly the same in every other software. All constraints are always the same. Now you'll notice that it did not budge when I created the IK, because now it's using that information, the zeroed out values, to be able to create an IK. And so that way it doesn't do that little jump, because it's already solved basically what it's doing is as you move this wherever this position is, it has to solve the rotation values of the other two joints like we mentioned, and it's going to use those internal values that are in there. If you haven't checked out the other videos on zeroing out, I strongly recommend you do. So now the other thing that we can do is we can add another constraint to this. I'm going to just grab this guy, move him over here. And this one's gonna pop, but there are ways around. Okay, tell you what, we'll add the constraint. You'll see how it does another little, I guess, knee-jerk reaction, and then I'll show you a method to improve that. So I'm just gonna lower this so that it's a little bit smaller. There we go. And we want the elbow or the knee, whatever this is, to be able to have it point to it, because this can spin, right? Like, I mean, there are many solutions to this IK. Telling it to solve for this point means that there's about an infinite number of because it's a circle, it's an infinite number of values that could be put that solves for that position. We want to lock it down so that it points in a precise place. So if I recall, it's let's see, because with a pole vector, this is called a pole vector. We're going to open it up and apply. There you go. I guess I did select it in the right order. It will control where it points. So see that no matter where I put it, it always points towards it, and the IK still maintains that directional control. So it did pop a little. So the easiest way to solve that is, if you don't want it to move because you get to your skin position and you want to add IK without anything jumping, what you do is before you add this as a pole vector, you match it to the knees position, and then move it relative to its z-axis. So, or in this case, the y-axis, depending on which one is the one you're rolling on. And in this case, because we created it on the ground, the y was up. So, okay, so I'll just show you real quick how you do that. So let me get rid of this. Now we want to do the constraint, right? But we don't want it to pop like it just did. So what you do is you just select it in this order. You select the object first, and then the one where you want it to go to, and you use the match tool. You can do that through modify match transformations, and you can match all. So if I do that, boom, the little thing goes there, and now it should be matching this object. Actually, it doesn't look like it's matching the rotation. So something. Let me just check here. I have a quick way of doing it. So match all transforms. I'm going to make sure it has the rotation as well. Okay, so now it's matching matching its rotation as well. So that means if I do Control Shift right click, I can go into object space for the rotation, find the axis. It was Z. So just grab this one guy, push it out so that it remains on the plane, and you can move it with this so that it looks right. I'm going to do this and then set up a pull vector. Pull vector, boop, apply. And you'll notice nothing popped by doing that because I matched it to the knee or the elbow, and then moved it along its plane where this triangle is formed. All right, and now if I move it along that plane, see, it's not actually affecting it because it's still pointing in that direction. If I move in this way, it'll start pointing in at this new object. And here's where you can get fancy. Like if you select this, it's not very good at showing you where things are. Normally, I have another thing that allows me to create a little line from it to the elbow, so I know that the elbow is pointing that, and it's easier to visualize. Um, but so, anyways, as far as functionality goes, we do have these lines being drawn when I select the IK handle. It's not very clear though, and you can at this point Control Shift right click and go world, so you can move it along in the world direction. So that's it. So with just these constraints, you should uh, be able to create the things that you need for your rig. Aside, but I can't stress it enough. You should use the hierarchy whenever possible. It's much more efficient and quite often does the thing that you need it to do. But constraints are very useful. We use them to have feet locked down. We have them to be able to move the hips without affecting the upper spine, and we can do all kinds of blends between objects. So it's not always just one object that you're constrained to. You can have multiple objects, and it does kind of an average between the two. So that kind of thing. So if you were to do here, I'll show you. That's the last thing. I grab this, and I make a duplicate, and I'm going to I'm going to make another one of these, then select those two, and make that the last thing. I'm going to use a point constraint with no offset, so that it's using the absolute positions of each one of these, and I apply it. And now you'll notice is you now have an average between the two. Wherever you put these two, that little node in the middle will always find the average between the two. And that's a handy thing because you can use that for rotation as well. You're having trouble with your elbow or your knee flattening out, add a orientation constraint blend between the calf and the thigh, and now you have something that's 50% between the two, and you can use that to soften out or tighten the knee in the skinning, and that's very handy. And it's just a little extra node with a very simple constraint on top of it. So this is the kind of stuff that we're going to be using to build our rigs, so that it's not just a skeleton. That's the difference between a skeleton and a rig. A rig requires a skeleton, but also has all these constraints and things and controls. And a skeleton is just bones and skin, or a sushi rig skeleton. That's the main difference between those two things. All right, so that should clear up what a constraint is, and should have a better understanding of how we can implement this inside our rig.